everyone, and welcome to our digital lesson for today. So, our focus for our lesson is going to be physical and chemical changes. So, our question that we're focusing on is, how can I tell the difference between a physical and chemical change? Well, let's start out by talking about the definitions of each. So, a physical change is defined as the process by which a substance undergoes a change that does not result in any new substances. And you notice that I underlined this bit right here. This is important because with a physical change, it's not going to come out with a new substance. Now, when we talk about a chemical change, that's the process by which substances are changed into a whole new substance with different properties. Now, you noticed I put that in yellow because chances are you probably don't remember what a new substance is because we learned about it way at the beginning of the year. So let's stop for a second and let's talk about the phrase new substance. A new substance is created when you have a chemical reaction or a change. Now, those chemical reactions occur when materials combine and they form a new substance by breaking or combining the matter. So, again, you'll notice I have a word in yellow, matter. And you might be saying, Miss Barber, I have no idea what matter is. I don't remember what that word is. Well, let's talk about it for a second. The word matter means anything that takes up space or it has mass. You might remember taking up space. Anyone remember? Volume, right? Yeah, okay. And it has mass, which means that there's matter inside of it. Now, that mass is made out of atoms. Atoms are the building blocks of matter, and everything around us, they're made of millions of tiny little atoms. We talked about atoms at the beginning of the year, and that's the basic structure of an atom. And if you remember, in the middle, we have the nucleus, which is made of the neutrons, which are a neutral charge, and protons, which are a positive charge. And then on the outside, spinning around really quick, you have these electrons, which are negative charges. So, just to recap, atoms are what matter is made of. And that matter is what we're actually focusing on when we talk about physical and chemical changes. The atoms are really important. So, when you combine or break apart these atoms, that's when you get a new substance. So, chemical reactions are actually the atoms that are doing something. They're either combining together or they're breaking apart. So when you have a new substance, that is going to equal a chemical change. So how do we know the difference between a physical and chemical change? Because let's face it, atoms are so small, there's no way that we can see them. I mean, millions of tiny atoms fit on the tip of a pencil lead. So how do we know that a change is occurring if we can't see atoms? Well, we call those signs. When I think of a sign, I think of like a sign on the side of the road, right? If I'm looking for Wendy's, what do I look for? I look for the sign that says Wendy's. Well, it works the same way here. How do we know that a physical change has happened? We're looking for signs. We're looking for indications or clues that help us know what's going on. How do we know that a physical change has taken place? Well, you can have a change in the state of matter from a liquid to a solid to a gas, or back vice versa. So for instance, I have a glass of water, H2O. That's the molecular compound of my water. Those are the atoms. It's made of 2 hydrogen atoms and 1 oxygen atom. Now, if I take my water and I put it in the freezer, what am I going to get? Ice, right? The thing is, the atoms haven't actually changed inside of my water. The only difference was that it turned into a solid. And those atoms got closer together and they compacted. When my ice melts, the atoms in the water, they spread apart. They start to heat up because there's heat being added to my ice. Even as I hold it, I don't know if you can tell, but I'm starting to get water on my hands because the heat from my hands are heating up the ice. So, this is a physical change, right? Because it's only changing the state of matter. It's going from a solid to a liquid. And if I stick it in the freezer, it can go back the other way. Another example of a physical change is when you have a change in size. Okay? So it says right here, ripping up a piece of paper. So if I take my paper and I rip it up into tons of pieces, have I changed the atoms inside my paper? Well, the answer to that is no. The atoms are still here. Nothing has happened to the atoms. Now they're just in each individual piece of paper, but I haven't actually broken the atoms apart. So it's a physical change. All I've done is change the size of my paper. Okay? Let's talk about another sign of a physical change. We also say the location. So if I take my keyboard and I move it somewhere else, have I changed the atoms inside? Not really. The atoms are still the same. I'm just picking up that object and I'm moving it to a new location. No new substances have been created, meaning no atoms have been changed. The last example I have is shape. So if I take my soda can and I crush it, am I changing the atoms? No, I'm not changing them. They're still in here. If I could get a microscope and zoom way in and see these atoms, nothing has changed. The atoms are the same. So it's a physical change. So a physical change means that the atoms haven't changed. They haven't turned into a new substance. All you're doing is just changing the size or the shape of an object. That's a physical change. All right, so now that we got that explained a little bit better, let's talk about a chemical change. And I think the chemical changes are a lot more fun because you're going to see really drastic sudden things that you wouldn't really expect to happen. So here are some signs that a chemical change has occurred. You could have a change in temperature. It could either get hotter or it could get colder suddenly out of nowhere. And you're like, where did this heat come from? That's the atoms combining or breaking apart to release that heat energy that's inside the atom itself. You could have a change in color. So if you have a purple object, for instance, and suddenly it changes black, that's a chemical change. I'm not talking about when you add food coloring to stuff. That's still a physical change because all you've done is change the color. But if you have a drastic change where something went from one color to another and you're like, where did that come from? You're actually seeing the atoms combine or break and cause that change to occur. Our next example is a production of gas. So when you have bubbling that happens or a gas is being formed, at the beginning of the year, we took the Alka-Seltzer tablets, and remember how we dropped them in the different temperatures of water? Well, what happened when you added the Alka-Seltzer tablets to the hot water? It bubbled and fizzed like crazy, right? Well, that's because that hot water was speeding up the rate at which the chemical reaction occurred. It was changing the atoms quicker than the cold water. That it was still changing the atoms, but just a little bit at a slower rate. The last sign that we have, well, no, not the last. We have a new substance is formed. So for instance, when you've been at a campfire, they throw the log on, right? Well, what comes off of it later? You get smoke that comes out of the logs as they're burning. And then later on, if you come back to that campfire, what are you left with? You're left with ashes. Those ashes and that smoke that's being put off, those are the new substances that are being formed when a chemical change is occurring. By setting that log on fire, you're actually changing the atoms inside of it. And the last example of a chemical change that you know that it's occurring is light is emitted. Emit means to give off. So think about the times that you've taken one of those glow sticks and you've taken it and you've cracked it and you can hear this audible that happens, right? Well, here's what's happening. You're actually taking two chemicals that are inside that stick, and when you snap them, it's combining those chemicals together and it's actually putting off light. It's really cool, but that is a sign of a chemical change. So any of these things can help us know that a chemical change is happening. You don't have to have all of them. You don't even have to have two of them. As long as you have one of these things that's happening, you know that a chemical change is occurring. So let's start talking about our lab that we're going to do today. Our purpose question, because you always have a question that you have before you get started. Our question is, when I combine substances, is it a physical or chemical change? And here are our materials that we're going to be using today. So I have 1 teaspoon of baking soda, I have 2 teaspoons of calcium chloride, and I have a sealed test tube with 1 tablespoon of bromothymol blue. So let's take a look at our supplies for today. So I have baking soda. Let me get the box open. And you might have used baking soda before if you have cooked in the kitchen. It's what we use to be able to raise like cakes and bread. And so if you look, it's a white powder. It's really, really fine, kind of like flour. It's a really fine white powder. And it has a little bit of a stinky smell. It's not going to hurt you if you breathe it in. We also have calcium chloride. Now, calcium chloride is a chemical, and you'll notice that it has a funky little label here. That's because it's telling me there are some warning signs for things that I don't want to do with this. One of them is breathe it in. You don't want to breathe it in. You don't want to waft this stuff because it actually has a chance to be able to burn you. So you don't want to touch it either because it can actually burn your skin. So not going to be wafting this today. So there we go. Calcium chloride. And let me pour out a little bit so you can see it. Okay. It is like these tiny little pieces, and they're like flat, and it's white. So that's calcium chloride. So we have 2 substances, 2 materials that are white. The last one that I have is called bromothymol blue, and I have it in a test tube because you don't want to touch it. It's a chemical again, so it's not really something I want to put my hands on. You notice that it's really dark. To you, it might look a little bit on the black side. It's actually really, really dark blue. So those are our 3 materials that we're going to be using today with our lab. So before we get started, I have a couple questions for you. You'll notice that there's a stop sign on the screen. When I get to a question, I'm going to read it, I'm going to ask you about it, and then I want you to pause the video and talk to your family and answer the question. So here we go. Question 1. What kind of change is this? So here's my question. I'm going to take my my calcium chloride and my baking soda, and I'm going to combine them together in my Ziploc bag. So I have 1 teaspoon. I'm following my list of materials here. I'm going to move this out of the way. Okay, so 1 teaspoon of my baking soda, and I'm going to combine it with 1 teaspoon as well of my calcium chloride. Okay, so I'm just going to gently zip that up and just kind of mix it together with my hands on the outside of the bag. So, question 1, what kind of change is this? Is this a physical or a chemical change? Okay, so now that you've had a chance to talk about it with your family, hopefully you said this is a physical change because you notice no new substances have occurred. I just mixed the powders together, right? They're both white powders. All right, question number 2. Can this mixture be separated? How would this be done? So if I wanted to separate my baking soda back out from this calcium chloride, could I do it, and how? Okay, so hopefully you said yes, you could separate this mixture back out. At the beginning of the year, we worked on mixtures together and how to separate them, and you could use a very fine sieve or a coffee filter to be able to get the baking soda to go through the tiny holes. So yes, this mixture could be separated back out. All right, question 3, we're getting closer. Our next question is to make a hypothesis. So remember, a hypothesis is an educated guess where you predict what you think is going to happen. So when we do a hypothesis, we always use an if-then statement, kind of like a cause and effect. So here's our hypothesis. If Mrs. Barber adds bromothymol blue to the mixture, then I think this because. So if I add, and I'm going to, the bromothymol blue to my mixture of calcium chloride and baking soda, what's going to happen and why do you think that's going to occur. Okay, so pause the video and talk about it. All right, so let's see what happens. All right, so I got to be really careful with this step because if I mess it up, then like it makes a huge mess. So here's what I'm going to do. I'm going to tell you first and then I'm going to do it. I have my mixture in the bag of my calcium chloride and my baking soda. I'm going to very gently pour my bromothymol blue into my Ziploc baggie, and then I'm quickly going to zip it back up, and we're going to see what happens, okay? All right, don't blink because you're going to miss it. Okay, here we go. All right. Okay, and then I'm going to mix it a little bit, and let's see what happens. Okay, so I'm going to hold this up. My bag is dripping. But you'll notice that there were some changes that occurred, right? All right, so I'm going to set this right here so you can still see it, but we can talk about it. Okay, question number 4. What kind of change is this? How do you know that it is this kind of change? So, is it a physical change or a chemical change? What signs did you see? Pause and talk. Okay, so let's talk about some of the changes that we saw. If you said a chemical change, that's right. What were the signs that you were able to see when I combined those materials together? So let's take a look at that list again, and let's go down this list and figure out what we saw. So the first one was a change in temperature. Well, it's really hard for you to see that because you can't really see temperature. I mean, sometimes you can, but not with this one. It actually got colder when I mixed it together. Like, almost like someone put ice next to it. So there was a change in temperature. It got colder. The next one is a change in color. You probably were super surprised by this one. This is one of my favorite labs to do because you start out with something that's this dark blue and then you get like this funky orange color. And I love it because clearly it's a chemical change because that instant color change, right? We also have a production of gas. You might have noticed that there was bubbles that started forming up. And I should have probably used a smaller bag for this because when in the smaller bag, like it starts to expand a lot. And that's because there's a gas that's produced when you mix those chemicals together. There was a new substance that was formed, and it wasn't really technically a new substance. Like, it's not like ashes or things that are like floating in there. So we didn't actually have a new substance that was formed from this. And the last one is light, and there wasn't any light emitted. But remember, guys, you don't have to have all of them for it to be a chemical change. You can just have one or two. And here we have the temperature, the color, and the production of a gas. So it was definitely a chemical change. All right. So I hope that you've enjoyed our lesson. I hope that you've learned a lot and that this has been a really great chance for you to be able to review the difference with the chemical change. So thanks for joining me, and I'll see you next time. Bye.